this. So what I do, I'll rotate a rod in a uniform magnetic field. B bar everywhere is into the plane, and there's a rod where the rod is, it is hinged about 0.2. Let L be the length of the rod. It's a conducting rod. Call iron. So what is the EMF generated across the rod? Why that EMF generated? Again, you take help of positive charge. This positive charge, in what direction it will have a speed, tangential speed. V equal to say R. Let it be at a distance R, let there be a hypothetical positive charge. It will have a tangential speed, and how much it is equal to tangential speed? V equal to R omega. No, because of that, you assume no. Will there be any like a force due to Lorentz force, or the field will exert any, magnetic field will exert any force on this charge particle? B bar velocity, so magnetic force will act in this direction. This magnetic force, what it will do? It will drift the charges. It will drift the charges. So this will make positive. This end will become positive. The deficient here, the electrons will get deposited here. The deficiency of electrons here is a positive charge practically. Then meanwhile, what will happen? As the deposition of charges occur, an electrostatic field is established. Like already we discussed in motional EMF, no, similar to that. And the rod is rotating about this end. Now further charge, what all happens here? It will experience an electrostatic force, and here magnetic force, and an equilibrium is established. Initially what happened? The Lorentz force here, or the magnetic force, will be greater, will be sufficient so that it will push the charge towards the right end or the free end. So a deposition of positive charge occurs here. Had the amount of charge builds up here, and a charge layer is set up at the ends, and this will produce an electrostatic field. Now the charge which is trying to drift will experience a force due to magnetic field, and also will experience force due to electrostatic field when these two forces are equal. When these two forces are equal. So what will happen to the charge? No more further drifting of charge will occur. And the charge built up on the ends, amount of charge built up will remain constant. So then a constant potential difference is set up here. Then at equilibrium, Fe equal to Fb. So this Fe should be equal to QE. This should equal to QVB. Q get cancelled, so E equal to, what is V? V is R omega into B. What is E is equal to dE by dR. Equal to B omega R dR. So R I'll measure from here. This is R equals 0. Let this be L. So 0 to E, 0 to L. So what is EMF induced? B omega L square by 2. So the rotating rod also will behave like a cell. And if you connect any resistor across it, an EMF will be generated. So why this is preferred? In applications, we don't do motional EMF. I'm making clear motional EMF is hypothetical. Just to understand all Faraday's law. Applications all are based on rotational EMF. And we don't discuss much numericals. What all we discussed till now, motional EMF, no, translational motion EMF, it's a hypothetical. We hardly use in any application, to be frank. 99.99% of applications are based on rotational EMF. And in books, very less numericals are there on this one. But we can manage because the torque ideas will come. No? That's why they didn't focus much. if you are very good in that rotation mechanics ideas, torque equal to I alpha, you can manage this also. Any problem, let them ask, you can manage here. Now what I should do? They're motion EMF, no? Here rotational EMF. It depends on angular velocity, magnetic field, and the length of the rod. Suppose I want EMF of 10 volt. Yes, I can go for it, no? Usually what is the length? Length, we don't go for several kilometers. Usually in applications, what happens if you go for the idle project, what is the length? Length will be of around 5 meter, 10 meter, or 20 meter. I should not go for length very large because the equipment will become very large. The rod is a now generator. This rotating rod is a part of generator. The size of generator should be less. So therefore the L should not be extend to several hundred meters, few 10 meters, okay. Omega, there's upper limit. What is the maximum value of omega which we can put it? I think 300 RPM, 500. You look at the fans like that in machines. What happen? Some 800 RPM, 1000 RPM is what upper limit for generators and field strength. So field strength, yes, I can bring a very powerful magnets. I can increase the B. So like that, what happen? An appreciable value of E will be generated. This is what we use in application. And now if I rotate the rod instead of this at the midpoint, exactly the axis is, so I'll here about midpoint I'll rotate. And how is the magnetic field? Magnetic field is directed in this way. Uniform magnetic field directed in this way. So let the length of the rod be L2. So this is the point O, P, and let this be Q. What should be the limit you are going to write? Take like this, no? B omega R dr 0 to L by 2. So then there's the EMF induced in the rod OP. So what is EOP equal to? B omega R square by 2, 0 to L by 2. B omega L square by 8. I think for EOQ also the same thing, magnitude. Both the lengths are L by 2, no? Then what to do this? If you are trying to replace this end will be, which end will be positive? Again, take positive charge inside that and B bar. Sorry, this is the B bar. Huh? Just wait. Some correction later we'll discuss. B bar of different direction. Here it is like this. Huh? Omega B bar is into the plane. Huh? Horizontal axis, not vertical axis. The rod is rotating about horizontal axis, passing through O. Omega, look at omega, or about Z axis here. No. So we are going to replace this B bar velocity. So this end will be positive, no? This is O, Q, this is P.
Sir, what is the axis of rotation?
Horizontal axis, horizontal axis. Look at what is the net EMF induced. 0, no? Across the rod PQ. You write KVL. So EPQ will be 0. There will be EMF induced in each part. The net EMF induced across the rod means PQ. Should be 0, that one. So which end will be positive? So here this will be positive, negative. This should be negative. You should give polarity like this. How to predict the polarity? You assume a positive charge, B bar. Look at the tangential velocity of that positive charge. Left hand rule, Fleming's left hand rule. B bar, tangential velocity vertically up. the pointing finger into the plane of the diagram, tangential velocity vertically up, thumb will point towards O. And for this part of the rod, B bar into the plane, tangential velocity will be downward and the thumb will point towards right, towards O. Okay, the prediction of the polarity of the ends is very important. Or put limits directly from minus L by 2 to plus L by 2. You'll get the EMF induced across the rod PQ and there'll be 0. So numericals, we need to think that one each part of the rod will behave like a one cell. Each rotating part of a rod will behave like a cell workout, because in numericals we have to think mathematically. Okay, minus L by 2 to plus L by 2 we write it, but numericals we should break up each rod. The rod has into two parts, and in each rod there will be EMF induced. The net EMF will be 0. Now instead of mounting the rod, let me mount the rod at 1/4 of the end. Now B bar, let me take out of the plane. Everywhere B bar is out of the plane. This L by 4 will behave like a cell. So the limit, so this you call OA B. So EOA B omega RDR 0 to L by 4. Which end will be positive? B bar out of the plane. So this end will be positive, negative, negative. This will be positive. So substitute limits. So B omega L by 4. So this will be B omega by 2 L square by 16. B omega L square by 32. Similarly, EOB, zero to 3 L by 4. B omega by 2. So 3L R square. So 9L square by 16. So 9B omega L square by 32. So what is the effective EMF induced? B will be at higher potential. So we know this EBA should be called the difference of that. B omega L square by 4. I can make the axis to pass through any point. The axis can be anywhere here. So, but make a practice of breaking up the rod. And that's what, because we have numericals. Okay, fine. So now this is about the rod. I'll rotate the disc. The idea will be same even for the disc. A conducting disc, iron disc of radius C, and there will be a magnetic field. So they iron disc. What about the potential difference across
Sir,
the circumference?
in before sum, how are you able to write the polarity, sir?
Polarity, assume positive charge inside it, inside the rod, positive charge, and it will have tangential velocity, and the positive charge in what direction it will drift. You assume a positive charge here, B bar out of the plane, tangential velocity V upward, thumb, the thumb will point towards B, no? So it will shift like this. And any positive charge here will experience a force like this, magnetic force. There's only best alternative method, or most easiest, which will not take much time. Your left hand arm, what when the joint pain should come. If there is no pain, then you have not learned EMI or Ampere's force or Lorentz force. Assume positive charge inside the conducting rotating rod. Inward action, the positive charge will drift. That end will be positive due to magnetic force. And now iron disc I'm rotating. I want the potential difference. What is the radius of the disc? Let it be A. It is rotating about horizontal axis, passing through center of the disc. I'll directly write EOA. Now again come for this one. B bar into the plane. Let me put clockwise. Now what should be EOA? EOA should be equal to B omega A square by 2. I'll write it. So what is this iron disc? Shall I assume it made up of rods? Then what is the EMF induced across one rod? That will be same across all the rods. Treat this iron disc made up of such rods. Such rods, if I add up, sum up, what do I get? I'll get a disc, no? So what is the EMF induced across each rod? EMF induced across the rod. B omega A square by 2. EOP, somebody is asking that. Yeah. P is a point on circumference. What is the potential difference between center of the disk and circumference? Mains or advanced troublesome questions. The idea of the rod only you should extend here.